All right, here we go. So on page 57, the formula, let's read problem number 25. It says, if a sports car in exercise 24 can accelerate at a rate of 7.2 meters per second. So I'm going to say the average acceleration is equal to 7.2 meters per second squared. So I stopped right there in the middle of the problem, and it says, how long does it take to go from 0 to 60? Now here's the thing. It wants to know the time. That's the question. Then it tells me the initial velocity, which is 0 miles per hour. And then it tells me the final velocity, which is 60 miles per 1 hour. This is another way to write it, by the way. Okay. Well, the only problem is that I want the velocity in meters per second because that's how we do things in the SI world, right? So how am I going to change that? Well, 1 mile is equal to how many meters? 1609, right? That's in the front page of your book. Well, that takes care of the miles. Now, what do I got to do to take care of the hours? Yep, it's 1 hour to 3,600 seconds. So that cancels the hours. So what I need to do is I need to multiply the top and then divide it by the multiplying or product of the bottom. So on my top here, oh, I do that every time. It's so silly. Okay, here we go. So if I multiply this through, I had to get my calculator out. I'm going to say 60. Let's put this in parentheses. 60 times 1609 divided by what? 3,600, right? So 60 miles per hour is the same as 26.8167 meters per second. Is that right? So now let me zoom out. Now that we've got some information on a piece of paper and I've done some conversions. The question was how much time goes by to make that happen? We were traveling at a constant rate or an average acceleration of 7.2 meters per second squared. Well, we need to figure out the relationship. And on page 57 it said that the relationship between these was the average acceleration is equal to the change in velocity over the change in time. So if I write that out here, if I say the average acceleration is equal to the change in velocity over the change in time, what I'm really saying is that the average acceleration is 7.2 meters per second squared, which is equal to the velocity, which is 6.8167 meters per second, right, all over the time. How long did it take? We don't know. That's what we're trying to find out, right? You guys with me so far? Is this making any sense to you guys? I'll zoom in a little bit. Is that better? Okay. So now algebraically what I want to do is solve for t. So if I do like if I pretend this is this over 1. Now here's the thing. This is really 7.2 meters per 1 second squared. Just like this is really 26.8167 over delta t s. So now if I cross multiply, what I end up with is I end up with 26.8167 meters seconds squared. See that? And that's equal to 7.2 meters delta t seconds. What am I solving for? Delta t, right? So I'm going to divide this whole thing by 7.2 meter seconds. So the meters and the seconds will cancel, and I'm going to divide over here by 7.2 meter seconds. So the meters cancel with the meters. Now I've got 1 second here and 1 second here. What happens? One of these cancels with one of these. And so my final answer should be 26.816, all that stuff, divided by 7.2, right?
Right.
And I get 3.7245 seconds equals delta t. Now, when we talked about unit conversions and we talked about dimensional analysis, because Mr. Adams, and this is going to be the hard part for you guys to get used to, because I wrote the units in there and followed the rules of algebra, if I'm solving for time, I would expect my answer to be in a unit of time. If I would have had meters here, kilograms, something other than seconds, I would have known I made a mistake. Does that make sense?
Yeah.
Is that the answer in the back of the book, by the way?
It's like 7 seconds. Yeah,
They rounded it off, yeah.
they did significant figures.
Why, yes, they did do significant figures. Aren't you a smart cookie?